Here today we are going to start with a practical test of the transformer to determine what is to determine eddy current. To determine eddy loss, hysteresis loss, and what we say copper loss. Okay. So in order to do this, we are particularly categorizing into two categories. The first one is open circuit test. Open circuit test. Okay. Then after we categorize into the second category, short circuit test. Short circuit test. Note here, in this both test, we are particularly going to first draw a circuit. Let's suppose this is an AC supply. I want to give a variable AC supply, so I can change the voltage whenever it is required. Okay. So then after I will insert a wattmeter. See here, I am going to insert a wattmeter. This is ultimately a wattmeter which will be supplied to the primary part of the transformer coil. Okay. Then after we will draw the symbol of the transformer, and this is how the circuit gets completed. In series we will adjust a ammeter, and in parallel we will be adjusting a voltmeter. This is open circuit test. Similarly, I will draw a second category, short circuit test, which is particularly for determining the copper loss. Okay. Since I am denoting this, it's a variable source. I am taking variable AC source. It's a voltage here. The voltage which is further connected to the wattmeter. Sorry, this is not here. This is actually here. Okay, do correct it. This is wrong. So this is connected here. It's a particular case of wattmeter. Now after this we will connect it to the primary coil of the transformer. Then I will take it to the secondary coil, which is this how circuit is completed. I will place here an ammeter. Note, this is the circuit diagram to test. This is in the open circuit test. It is particularly to test core loss. So core loss is determined. Here it's copper loss. Copper loss is determined. Here primary source, SOUR source, is at low voltage. P being constant, P is equal to IV, so is constant. So if low voltage, then I became max. So V low but I max. Do note that core loss is voltage dependent. But copper loss is current dependent. What is loss? I square RT. How this occur? P is equal to IV is equal to constant. If voltage drops, current starts increasing. So is a constant. V inversely proportional to I. As the voltage drops, current starts increasing, or we can write I inversely proportional to V. V drops, I start increasing, and it further supports to as I. So as the I increases, the heat loss increases. So it particularly promotes as the voltage drops. The voltage drops. The it promotes the power loss. Okay. See here. The secondary side here. Here, the secondary side is at low voltage. Why? Because we can have max current, max current, current, so that COPP here, copper loss is determined, determined, and core loss becomes negligible. Do note that here core loss also occur, but as we have low voltage side, this is high voltage side. High voltage means I low. Low voltage means I max. This is high voltage side, so I low. This is low voltage side, so I max. This is how, what is the functions of this wattmeter? Wattmeter actually measures the power drawn from the source. And what is the source here? It's a variable AC source. We can alter its potential difference on what we BRMS. Okay, this how we particularly do the short circuit test and open circuit test. Note that once again I repeat, this is a circuit diagram for open circuit test and short circuit test. And one more thing I have to mention here: open circuit test voltage dependent and it's determine core loss. What is the core loss? Hysteresis loss and eddy loss. EDDY, eddy loss. This is very important. Do note that here I have taken low voltage and current max. So I could not take, because of the limitations of this ammeter, which cannot measure very high current, we are particularly assuming here low voltage and high I maximum. See here in open circuit test, we particularly does not supply any load. The secondary coil is in open form, and as the variable source passes its current through the primary coil of the transformer, it will generate a flux which will link to the secondary coil. Ultimately, this will not pass, but after a certain instant of time or magnetic saturations, we say, after some losses, the current will again returns and faded it to the negative terminal, faded it to the opposite terminals. This how it determines the power drawn from the source. This ammeter measures the current which is connected in series combination. This voltmeter is connected in parallel combination. After wattmeter, here I have connected voltmeter in parallel combination, in series combination. Note that this how we calculate, and this how we do what the transformer and open circuit and short circuit is. Okay, fine. Thank you.